All right, welcome to the Blockchain Journal Club. I'm Carlos.
And I'm Perry.
Hello, Perry. How's it going?
How about you?
It's been a while.
For the listeners, yes. For
We're
us, not
we're
really.
late. We're late on this one.
Yes. So maybe we should say that
Maybe you should apologize, Perry.
I should apologize.
Yeah, I think you should apologize.
So we have another podcast ready to go where we interviewed Jakob from the paper we discussed in episode 3, I think.
ABC Blockchain.
That's right. So for those following the Facebook, I advertised that that podcast will be coming out soon, but I guess we're delayed now because we're just waiting
Because
for
of your
Jakob.
thesis, Perry. That's why we're delayed.
A bit
I
because of
just
my
realized
thesis.
that it was because of that. Because I asked you if you wanted to record an episode like on Monday. No, on Friday, I think, or something like that.
Yeah.
And yeah, you were doing your thesis.
Yes, but I guess also the Jakob podcast will be available soon, I guess.
Yeah, I don't know if which one we should release first. Maybe this will happen after that one. I don't know.
I think the Jakob one should be released first.
Yeah,
Actually, maybe it doesn't matter. I don't know. We'll figure it out.
it does not matter. But anyway, I'm gonna edit it tonight.
Sounds good.
Yeah, it was a good one though. I really liked it.
Yeah, Jakob is a great guy.
Yeah, shout out.
Shout out Jakob.
Jakob. Okay. Anyway, otherwise, how are you doing?
Not bad, trying to wrap up my thesis. I thought I would have submitted by today, but I
What?
got what?
You haven't wrapped it up?
I got caught up in like references, like just trying to figure out what all my references should go.
Oh, really?
Yeah, like
That's funny.
why is it funny?
I don't
You're
know. I
funny.
mean, okay.
No,
That's
why is
more
it
than
funny?
enough. I can't handle that kind of emotional
Why is it funny?
attack. I don't know. I always just like write a sentence, put in the citation, move on. You know that it just kind of does itself.
Yeah, so the thing is, I started writing this last June.
Okay. Yeah.
So some stuff I'm like, okay, this citation goes here, and then I would look at the citation, I couldn't find where, like, what part I was referring to,
Oh.
and then I had to maybe like change the citation. You know, also like
Okay.
in books, I wanted to put the chapters in for where I'm citing.
Wow. Yeah, I'm thinking of starting up my LaTeX for my thesis.
Yeah,
It's
it's
a
a
big day when you
challenge.
do that.
Yeah,
No, but I guess yeah, I don't know how useful it is, to be honest,
to do what?
to like start writing your thesis before you've finished all your projects. You know,
Yeah,
like
so
I
I
know what
did
the
it.
chapters are going to be, but
Yeah,
who knows?
so I did that, but I like I just said, like it becomes like it's spread out over such a long period of time that sometimes you forget what you wanted to write, and then have to rediscover how to phrase things. And
Yeah, and I
like I don't
guess
know.
Bill's pretty like thorough with going through it. Like he's actually going into every part you write.
Yeah, he read every part, and now he sent me the last corrections on Sunday,
Yeah,
and then I took to today to finish them up because I also have to submit our third paper.
sick. You submitted it?
Yep, submitted.
Amazing. Wow,
Got
that's the
three
hat
paper,
trick.
got two published, one submitted.
Amazing.
Yep,
10 on 10.
10 out of 10.
So
Oh, that's all right.
what was I going to say? Are you guys using Overleaf?
For the thesis?
Yeah.
No,
Huh. For anything? You're still doing Dropbox?
we used Overly for the last paper.
Okay.
Yeah,
I can't imagine not using Overleaf anymore. I
yeah,
used to be really against it.
but I think I can't either. Like especially with collaborations, it's impossible.
Yeah.
I don't know how we did it. Like we would send PDFs, I guess, and people annotate PDFs.
Oh. No, but what if like someone else is actually writing the paper? Either you use Git or
No, we would
what do you
just
like?
send PDFs. If I'm writing the paper, I would
Okay,
send everyone a
so
PDF. They would read it, send me like comments with like sticky notes or whatever,
yeah.
and I would have to implement them.
No, but that's really centralized.
Yeah, what we're trying to avoid with the topic of today's paper.
Yes, actually today's is a nice little kind of shift in tone, I would say, for today's paper. Anyway, should we get into it? Let me just say first, this is a blockchain journal club. So the idea of this podcast is every week, Perry and I discuss a paper related to blockchain. So usually it's an academic paper or some kind of, oh, there's the Diet Coke. Very nice. I was considering bringing mine, but after we recorded an episode while I was drinking Diet Coke, I noticed there were a lot of like slurping sounds.
I also noticed that right now you interrupted yourself and didn't finish the sentence to comment on Diet Coke.
Well, you flashed it in front of me.
That's how addicted you are.
Yeah, I'm really going through them quite fast, to be honest.
Shout out Diet Coke. Shout out Warren Buffett.
Yeah.
And Bill Gates. He drinks all kinds of Diet Coke.
Yeah. I took a screenshot from the Netflix documentary of his fridge when he opens it. He has a fridge just for Diet Cokes.
It's so funny, yeah.
When he goes on his like retreats to like think about how to fix the world.
Yeah.
He has his cottage, he has his Diet Cokes, and his like stack of books.
That's what gets him through the night, the Diet Coke.
Apparently he said that he feels really guilty that he wasn't able to prevent the whole COVID outbreak, He was like, I should have done more, I had a feeling that there's going to be some kind of crisis.
Yeah, but the error bar on the time scale of when the crisis will happen is probably huge,
Of course, as with many other possible crises. No, but apparently there's a vaccine coming through phase 1.
Yeah, I saw that, but doesn't it usually take 10 years for vaccines to come out?
I don't know. Probably this one they're like super fast tracking,
Expedited, yeah. Anyways, we'll see what happens as it happens.
Speaking of shorts, I'm thinking of shorting that company. The stock went crazy high when they announced like phase 1. There's 3 phases, and each one has like a 70% failure,
So chances are it's going to fail like hard.
Yeah, like it's super likely that it's going to fail.
Only 10% chance it passes, yeah.
Yeah.
It's like 30% of 30. So it's 30% times 30% of success, right?
Yeah, exactly.
Not going to happen.
Be a good short. Hot tip, boys. Okay, so
I don't know how to do that though, but yeah, it's fine.
Oh yeah, actually I wanted to ask you how to do that. So you taught me that I can buy an ETF that shorts the S&P.
Yeah, but I think you need to you go to the futures market to short individual stocks.
I mean, when I buy a stock, there's like the drop down menu that I can click short.
Oh, okay.
Once I do that, I don't know what happens after that.
I don't know either. I'm sorry.
Damn. Because I always have this question: when you short, do you pick a date that you have to buy it back by?
Not for the ETF.
Not for the ETF, yeah. I don't know how they're doing with the ETF thing. I guess they're like constantly buying and selling.
Yeah, I think they just manage it for you. Manage the buying and the selling for.
Yeah.
Honestly, I don't know.
Because on the ETFs, you're paying a fee, eh?
Yeah.
You're paying a management fee.
That's true for all ETFs, I guess. Yeah.
Yeah. Because I don't know. I had this. I was talking about this with another friend, Haberman. Shout out Haberman. That he's like.
Shout out Local Logic.
Yeah, Local Logic. Oh yeah, maybe you can have Haberman on.
Hashtag shout outs. Yeah.
Yeah, he. I don't know. He likes to use this app called Wealth Simple.
Okay.
I don't know if you heard of it.
Nope.
It's like you don't do anything. You just give them your money, and they automatically invest everything for you with like some AI.
Okay. And they take a cut, obviously.
Yeah, they take a cut. And we're discussing like if that's better or if it's an ETF is better. I don't know. Or picking your stocks directly. Anyway.
Yeah, who knows?
Whoa, big gulp there. Okay. Sorry, listeners. As I was saying, this is a podcast where Perry and I discuss any paper related to blockchain technology. And we usually like to go kind of in depth and try to learn as much as we can from it. Try to summarize everything, explain it so that other people can learn about it and hopefully become interested in this kind of stuff. All right. So today's paper is called Blockchain Distributed Ledger Technologies for Biomedical and Healthcare Applications. So this, I think, is our first applications paper.
Yeah, and I'm thinking we should do like a month of applications or something.
Yeah, we should do a month of applications. I really wanted to do an episode on hierarchical wallets. I don't know if we can squeeze that in to like close off our little series on wallets.
Okay. Yeah, maybe we'll do that next week. We'll see.
I think you're right. Okay, let me start sharing my screen. Share. Did you read the paper, Perry?
I read the paper.
Very nice.
The first half was Bitcoin, so I skipped it. Well, I skipped it, but I went through it quite quick.
Yeah, I know. But I found it was really well explained.
Yeah, it was. It was really well explained. Yeah, for real.
So this is in the Journal of the American Medical Informatics Association. So the idea is it's a review where I think the authors were trying to get the medical community to first understand what blockchain is and then see what kinds of applications are relevant for anything related to healthcare.
Right.
And so, yeah, the authors are Tsung-Ting Kuo,
Nicely done.
Yui Kim, and Lucila Ono Machado from UCSD San Diego. Nice. This is from 2017. Top peak blockchain, golden age.
I don't think it was though, because the prices they quote are quite small. Actually, no, they're quite low.
There was that May 27th. It was accepted June 30th, 2017. That's
like I think
peak.
No, because I think the Bitcoin price.
Yeah, they do quote a price. Here it is.
$1,200 US. That's nothing.
Yeah, you're right. Weird. So I guess it was right before the exponential phase. You see my screen, right?
Yeah.
Okay.
It was actually, I don't know when the exponential phase was. Wasn't it like December of some year?
I think December was the peak because I remember like
but
at Christmas I was going crazy. And
yes, but 50% from the peak was like 3 weeks before the peak, you know?
Yeah, it's true.
So this could be like, I don't know.
Maybe
like
they missed a zero.
No, but this is June, right?
It's June.
This is 6 months from the peak.
Well, revised May 22nd. So revised after it was accepted? Okay, I guess, revised before it was accepted. Okay, they went through a revision phase, as I am going through right now. Okay. Received February 22nd, 2017. So that was way before, I guess, almost a year before.
Yeah.
Okay. So blockchain distributed ledger technologies for biomedical and healthcare applications. The reason I like this paper first was it's well cited. So I like that. The writing is very good, I found. It goes just enough into the technical details to be able to really understand the applications. And it tries to directly compare a blockchain approach to a non-blockchain, or probably what we'd call a centralized approach, which is a subject of conversation I've had with Perry like a billion times. We really like the technology, sort of the theoretical aspect of these sort of systems. But then we kind of ask ourselves, like, okay, it seems like it worked very well for tracking financial transactions. Is there something other than that it can do? Yeah, Perry?
Maybe not just tracking, right? But like it seems like it solves a problem, I guess, for in financial systems.
Yeah.
But definitely. Now, can you extend the solution? Can you extend the solution or this decentralization to solve some other problem in some other? So we've taken, well, like not we, but blockchain has solved or is a potential solution to this financial systems, but I don't know what else it can do.
Yeah. And I guess in part, it could be that there was a big wave of hype that said, okay, blockchain can fix everything. And probably for a lot of those things, it wasn't the case. Also, because it's such a new technology that there hasn't been time to really develop like a clear application. Since Bitcoin was developed over 10 years ago now, like it's clear now that it solves a specific problem very well.
Yeah. So also I should say that, people have applied. Yeah. So people have found solutions or people have attempted to find solutions for a lot of problems, but it's just like, are these solutions useful is the question I guess we have. Like, are you gaining anything by using blockchain in things that work well in a centralized system?
Yeah.
Yeah.
And it also becomes extremely complicated to do to make a good comparison, It goes into all kinds of different industries where, there's like, I mean, at a certain point, the financial application is so simple that someone from a computer science degree or just a math perspective can completely understand it and say, yes, this works. But then when you start getting into things like biomedical or, whatever, insurance, then a whole bunch of other factors come in that maybe you don't really, you can't really weigh how much they need to be addressed. Anyway, but I was thinking we could go through the paper in order and just do a little review of the basics of blockchain. I don't know what you think, Perry?
Yeah, sounds good.
Since I found they made nice figures and kind of highlighted some very important concepts. So this is my highlighted version of the manuscript. So like Perry said, the first instance of decentralized blockchain system applied to a real world problem was payments, and more specifically, it solves the problem of preventing double spending in a system of transactions where there is no central authority. And so that's something that we went into in a lot of detail with our guest, Jacob, with his blockchain proposal, which will come out soon. But the main idea is that if we think of a system of payments as sort of transferring of wealth, in order to be able to transfer some wealth to someone else, so say Alice wants to transfer 10 coins to Bob, she needs to prove that she in the past received at least 10 coins, right? So this would be a valid transaction because she's saying, look, Alice, I'm Alice. I can prove that using what we've talked about with like keys, public key cryptography. I can say I've received 10 coins in the past, and then I can send that over to Bob. And this is nice, but Alice can also do the same thing, except at the same time create two transactions where she sends 10 coins to Charlie and 10 coins to Bob. And each of those would individually have a valid chain of ownership, because Alice would be sending 10 coins that she legitimately received to Bob, and Charlie would see a legitimate chain of ownership, of transferring of ownership as well on his side. So without a central authority to say, actually the transaction from Alice to Bob, we're going to say comes first, and therefore the transaction from Alice to Charlie is invalid, meaning there needs to be some kind of timestamp on these transactions or some kind of ordering that an entire decentralized network needs to agree on, then double spending can happen. And if we were to implement something like this with a centralized system, maybe we just designate someone to look at all the transactions and impose some kind of ordering on them and say, everybody looks at that ordering, and then they can always know whether or not there's some double spending happening.
Yeah, so I guess for a bank, it just happens like whatever transaction the bank receives first is the first transaction, right?
Yeah, exactly.
And I guess this is the only problem Bitcoin solves.
Absolutely, because the others are already sort of using technologies that have already existed for a long time.
I think the novelty of Bitcoin is really solving this problem, getting double spending to be detected in a decentralized way.
Yeah.
And avoided. Yeah, to eliminate double spending in a decentralized way.
Exactly. And so here's figure 2, where they kind of make an abstract figure out of this concept. So usually in centralized systems, you have participants, which are in this case called nodes, which communicate with a central authority. So in the case of a bank, the bank would be providing the ordering of transactions, although in reality, banks I don't think look at things like that, but the point is it's kind of analogous. And then that's cool. There's a consensus, but first of all, everybody has to trust that the bank is doing this honestly, that the bank is not saying, you know what, Bob, I don't like you, I'm not going to process your transactions, or, draining his funds or whatever. And the other thing is that it becomes a central point of failure. And I guess I would say breaches of trust count as instances of a failure of some kind, but you can also think of a hack or something like that.
Or I guess even a power failure, right? Or something.
Or power failure, yeah. So anything that happens to the central authority automatically disconnects all the nodes of the network, and they can no longer process their transactions, right?
Yeah. Also, I read. I don't know if this is true, but I read Assange from WikiLeaks.
Yeah.
Apparently, he was denied access to all banking.
Oh, for sure.
So he had to he had to use Bitcoin just because the banks were blacklisting him. So this is also true for people that get what do you call this?
Censored.
Yes, that's the word. We always say censored.
Yeah. Censorship.
so it's censorship resistant, right?
Yeah. Bitcoin, I mean, it's happening already with, a lot of cards are censoring transactions that are used to purchase cryptocurrency, right?
Yeah, or even gamble.
Yeah. But I don't know if that's, that's still inherent to a decentralized system. Yeah. The point is that once you remove this central intermediary, then the entire network becomes the thing that's verifying transactions. And so we end up getting a lot of redundancy, and then nodes can come in and out of the network, and we still have, the system can still function. And at the same time, there's no one controlling who goes in and who goes out. So there's no one saying, Bob, you're not allowed to join this network. Yeah.
I guess a majority can sort of decide that though, right?
Yeah. Okay, sure. So yeah, once we get to the mining, yes, the point is it becomes some sort of majority consensus. Yeah.
Because I'm just wondering, like the network can vote to say like, Carlos, your transactions are invalid always, And if anyone ever processes your transaction, no one mines on top of that block.
Yeah. But you can always generate a new identity, right?
Yes. But you can always track the coins as well.
Yeah, like no coins, any coins coming from this wallet can't be spent.
Yeah.
Which is something I was wondering, the paper mentions like burning coins that use proof of burn, right? Where you just decide to burn some coins.
Yeah.
And they say you do that by sending your coins to a null address. And I was wondering, like, how can you know that the null address, no one, I was saying maybe this is done in such a way that nobody knows the secret key to the null address. But I think more likely it's what's happening is the network's probably censoring anything that's trying to spend that address, no?
Yeah, but I guess maybe you just pick a random address. Then finding the private key associated to that address is impossible.
But how do you do that without knowing that? How do you do that without having the chance that somebody like conveniently generated that address?
Maybe a random number.
Yeah, but then you get to the whole problem of randomness on the blockchains.
Yeah, sure. I guess the Genesis block and yeah, I don't know. Or maybe it's really just burned, right? Maybe it's just like yeah. So like the balance of this address is set to 0 after every block.
Yeah, exactly. Some kind of hard coded rule. Yeah, for sure. Anyway, okay. So back to this. Now. So yeah, in this case, we have what's called a peer-to-peer network. So instead of a client-server system, which would be the centralized system where everybody's a client and the server has some special authority, we have a peer-to-peer network where everybody communicates with each other and everyone is equivalent in terms of authority. And the way Bitcoin achieves this ordering of transactions is through this blockchain structure where the network agrees on a sequence of transaction blocks. And adding a block becomes what we call mining, right? I don't know if they have a figure of mining.
Of the blocks,
they
right?
do, yeah. Yes. So what do we do with this? Yeah, so all Bitcoin is trying to do is everybody on this network is constantly sending transactions to the rest of the network, and miners are listening to these transactions, assembling them in blocks, and then appending them to this shared data structure called a blockchain, right? Where appending this new block, so the most recent set of transactions, is quite a costly process in terms of computation power. So miners have to invest a pretty large amount of energy in order to be allowed to append a block. This is done, first of all, to ensure that blocks are spaced out enough in time so that it's easy for the whole network to be synchronized. And also such that in order to undo or invalidate a valid transaction, a malicious party would have to redo the work that was involved in creating the honest blocks. So every time a miner burns energy to create a block, that energy is actually kind of stored as security on the blockchain. I don't know if we need to look at this, right? It's kind of showing an example of like nonces and things like that. We can probably refer to an earlier episode.
Yeah, I think we're good.
Okay, but the point is that what's the relevant takeaway for this paper? I guess the fact that mining adds a very strong layer of security to these transactions. So if I were to try to say change a record that has already been accepted by the network, I would need to redo the work that all of the network has already gone up to the point that I'm trying to modify. And this would be so expensive that it should be so expensive that it's not even worth doing. So This adds a property to the blockchain known as immutability, which means that first of all, by construction, the blockchain is immutable, meaning any instance of the blockchain, if you were to change any data in it, the whole blockchain would be able to detect that some data was changed on it. And on the consensus level, it's also immutable probabilistically, because in order to modify the version of the blockchain that the entire network agrees upon is the correct one, you would need to spend a lot of energy, computational energy, and incur a very large financial cost. So it's not to say that the blockchain can never be sort of rewritten, but it's just to say that there's a very high cost to doing that. And usually it's more beneficial to participate as an honest miner than otherwise. All good?
All good.
Okay, so I think, let me see if I hit all my highlighted points. Okay, so this is what they call the blockchain 1.0 technology, where they used the problem that was trying to be solved is really how do we get rid of double spending in a peer-to-peer payments network, right? So that includes basically Bitcoin, Litecoin, Monero, which is kind of like Bitcoin and Litecoin, but they introduce more privacy elements. So that's kind of the first generation of blockchains. And then they talk about blockchain 2.0, which sort of generalizes the idea of a transaction in that it no longer, essentially a transaction is some piece of data. In the case of blockchain 1.0, it would be a piece of data that tells you how many coins someone's trying to spend, from whom to whom. From who to whom? From, I don't know.
There's an M somewhere.
Yeah. In one or both. Definitely not neither, though. Probably not neither. So the data in blockchain 1.0 structures is just sort of a quantity and whether or not a transaction is valid. But as these projects evolved, you can kind of put any data along with these transactions. So the transactions, you can think of them now as records, and the records can now contain any kind of data. So in this, what this paper is going to focus on would probably be, I don't know, patient records or insurance claims or things like that. Any kind of data that you want to have this property of immutability, such that nobody can modify it. And also a property that it's managed in a distributed and decentralized way. So nobody has the authority to deny you access to this data or overwrite or, you know, do any kind of tampering with this kind of information. You can essentially input that data into blockchains that follow the 2.0 protocol. And they introduce the idea of a smart contract, which we'll probably talk about in later episodes. But it's that you can also not only put in an arbitrary data as transaction data, but also the transaction, when it's processed, can execute code that's not just the sequence of steps that's needed to verify a financial transaction. But you can start building apps or doing more complicated computations on these transactions that start to let you do a lot more things. So that's kind of the main feature of Ethereum, which is the second biggest crypto. Is it still second biggest?
I think so.
Yeah, probably. So yeah, Ethereum came out, I think, 2014 and introduced the idea of a smart contract. Although Bitcoin already has the idea of a smart contract, it's just that they are very hard-coded and limited in terms of what they do. And all they're trying to do is verify signatures and spending.
Yes, I guess Ethereum is like a Turing-complete language that lets you make any smart contract.
Yeah. So you can say things like, you can spend this money if 5,000 blocks have passed from today or something like that.
So I think Bitcoin can do that as well.
Yeah.
I think Ethereum lets you do things like much more complicated things, like
accounts and things like that.
Or like, yeah, if the temperature according to this website drops below 0, pay me $1,000 or pay this guy 1,000 Ether.
Yeah, exactly. Okay, so And it says Microsoft adopted Ethereum as the core of its new blockchain as a service on the Azure cloud computing environment.
Sweet.
Interesting. All right. And then, so in blockchain 3.0, so the distinction between 2.0 and 3.0, the distinction between 2.0 and 3.0 to me is a little bit fuzzy, because I would say Ethereum kind of from the start was already solving non-financial problems. But what they say as a blockchain 3.0 system is any non-financial application of the distributed ledger technology. For example, Namecoin, which applies blockchain technology to domain name server and identity management. So you could register your domain on the blockchain network instead of, the usual DNSs. So yeah, it's the idea of extending this kind of technology outside of just processing payments.
So Alessandro worked on the ENS, right, which was the Ethereum name server.
Yes.
Which is the same thing, but on Ethereum.
Mm-hmm. So I guess it's just since domain names are essentially records that are associated to a specific IP address, what the blockchain would store, instead of just payment transactions, it would store which IP address can we reach from which domain, right? So this kind of data is not a payment data, but it still needs to be immutable. It still needs to be widely accessible, and we don't want anybody having special permissions over this, except for the person that actually created this record. Okay, so I think this paper is gonna focus on what blockchain 3.0 applications can do. So this is an example of a double spending attack on blockchain, on Bitcoin, which
do you know if these numbers are mean anything? I feel like they just made these up, right? These 1.0, 2.0, 3.0.
I have heard of blockchain 2.0 and I've heard of Web 3.0 is what I've heard of.
But isn't Web 3.0 just blockchain, Ethereum?
Yeah. Yes.
There's also Ethereum 2.0.
Of course, yeah.
So everything has a 0.0.
So if I go blockchain 3.0 on DuckDuckGo, oops, 3.9.
Yeah, 3.9.
3.0. What do I get? What is blockchain 3.0?
What is DAG?
Everybody has their own definition of 3.0. So yeah, 3.0 is what I've heard of. So in Web 1.0 was kind of like static web pages, one-way flow of information. So you look at a picture of a cat. 2.0 is social media, so you can upload your own content and have sort of dynamic websites. 3.0 is, they say, the rest, everything. So
until 4.0 comes out.
Blockchain integration, I guess. This is a very weird website.
Anyways, whatever. I guess we get the idea. The 3.0 for them is just what you said, right? Applying blockchain to other things besides money.
Yeah. This sounds like a garbage website. They introduced DAGs like they're some kind of high-tech, top secret thing. Eh? It's hilarious.
Maybe they are.
Maybe. All right, whatever. So the point is, the main distinction is blockchains that are applied to payments and blockchains that are applied to other problems. And so this paper then sort of lists some potential benefits and then some potential drawbacks to using blockchain in the medical sector, which I don't have any experience with. I don't know about you, Perry.
No clue. You do biology though. So.
I do have a master's in biology. Very proud of it, and nothing to do with medical anything, but I can kind of see where they're getting. This paper is very clearly written, so I understood quite a few things. I like the example they give of ransomware.
Yeah, that's the one example for why the bad stuff about blockchain.
Yeah. So they say, look, blockchain has been getting some bad press because a lot of people are getting, hacked, and then the hackers want Bitcoin in exchange for whatever their passwords or something like that.
I guess the point is they hack you, encrypt your data.
Yeah.
And then say, we'll decrypt it for you only if you give us 10 Bitcoin or something.
Yeah, definitely. What I think though is the people that get hacked they could probably get away with not even doing anything and asking for 10 Bitcoins, you know?
What do you mean?
Like, I don't know. I think this happened to my mom, actually. She got an email saying, hey, we've guessed your passwords. Send us 10 Bitcoin and we won't like share them or something. And then
But
some people would fall.
no, but I think the point here is that they're hacking you, taking your data,
Yeah,
and encrypting it.
yes.
They leave you with your data, right? They just
Yeah.
add a password to it.
Mm-hmm.
And now you have to guess the password or you lose everything.
Yeah, for sure. And send them 10 Bitcoin. I don't know how you managed to send someone 10 Bitcoin though.
If you lost your password, if you've got hacked, you mean?
Come to our workshop, Beginner's Guide to Bitcoin.
Yes.
Okay. Anyway, so yeah, sometimes Bitcoin gets bad press, as because, you know, there's no identities associated to Bitcoin addresses, so bad people can also get away with using these networks without being censored, just like good people can do it for good reasons. Like Julian Assange, if you think he's a good guy, needed to, I don't know, accept money. I'm pretty sure you can donate to WikiLeaks on with crypto and all this stuff.
Yeah.
Okay, so they're saying the technology behind Bitcoin can be used to help instead of harm health systems and biomedical research. So the starting point is to compare a distributed ledger, which is just a way of storing records in a way that's immutable and decentralized, to what's widely used today, which are called what they call distributed database management systems, like SQL and Oracle and things like that. So they say distributed because when you use a database that's centralized, it doesn't mean it's not distributed. So centralization, by being centralized, they mean that certain users have special permissions on this data, and by distributed, they mean that the data actually lives on multiple computers. So there's redundant copies of it. So things like AWS, Amazon Web Services, or Google Cloud, or things like that. Amazon can at any moment hit delete on all your data or decide to share it with whoever they want. But it's very unlikely that if someone bombs, I don't know, Amazon servers in Seattle or wherever they are, that your data is going to disappear, because they've essentially distributed their data across many, many servers so that it's not vulnerable to these kinds of attacks. Good?
Yep.
Okay, so they list through the possible benefits of blockchain. So the first one is they say it's a decentralized management system. So I think I just went over that, meaning in a decentralized system, no one has to give up control over the processing of transactions, right? So essentially, if you're, I think the example they give is a hospital, and you want to be able to share your patient's records with another hospital, you essentially still control your records, right? They know that other hospital you're giving it to is not able to modify or edit whatever you've shared with them, and you essentially kind of maintain control over your data.
Why is this like right now? Like you just fax it, I guess, or whatever. I don't know why
Yeah.
people still use fax, but
Yeah.
why does this like? How does this help you at all?
Yeah, so a lot of these are kind of very high level, and I wish it had gone a little more in detail. But I think it's more like if, I don't know, maybe like a patient in one hospital is asking for a prescription in a different hospital, the hospitals like need to agree on like which version of the records, that patient's records, to use. And like maybe the two hospitals don't trust each other, so they don't want to like let the other hospital kind of say what that patient's records are now, you know?
Yeah, I mean, I guess we can construct these. I don't know how relevant this is though. That's the problem, I guess.
Yeah.
Like I don't know if this is actually happening in the real world. where like a hospital doesn't trust another hospital, and like
Yeah.
they don't believe the facts that they're getting from the doctor or whatever.
I
Anyways,
think there are examples where things do get tampered with. Like I know in my high school, one of our teachers, he's never my teacher, but uh, he like he had gone to jail for he was like a pretty like high impact scientist in the US, and I think he was the first scientist to go to jail, like for science, like for science
okay,
related crime. And he had like forged a bunch of results on a clinical trial,
I see.
and he got caught and he went to like real jail, you know.
Yeah, yeah.
And then my high school hired him. Pretty good bargain, probably. Like
Nice.
PhD high school teacher.
Yeah.
Anyway, yeah, maybe there's some like tampering, right? Or I don't know,
Yeah.
prescriptions. I
Okay.
would imagine are things people want to like forge, or
Right.
and I guess um, I don't know how that relates to like the decentralized aspect of things, like because usually like the entities in these networks that have control over the data are probably like quite trustworthy, I would imagine. Like I can't
Like
imagine a
you
hospital
trust,
like
yeah, you trust them with your life. Like
yeah,
I don't know.
yeah, like you have
Anyways,
to assume that there's corruption like going pretty high up, right? Anyway, so yeah, the next benefit they bring up is an immutable audit trail. So because blockchain is essentially like this timestamping of immutable records, any kind of update or that happens on the network is fully traceable, and any change can be um, sort of brought back to its origins. And this, I think, makes a lot more sense, and it's probably linked to this other benefit, which they call data provenance. So I guess there's no jump between records where you don't know what happened in between, right?
yeah,
Like maybe at some point you fax your prescription to someone, and then someone can like white out something on it and send it over to another hospital, and at that point you kind of like broke the link, on
or I
that
guess
record.
you switch doctors or something, and like or you don't go see a doctor for something, and like you break your leg, and they don't know you took some drug for the pain or something.
Yeah, yeah,
Yeah, I can see the use here. Like you want to know what the person had, or like maybe his current state depends on all the past state at every point in time.
hmm
You want to maintain that past state forever.
yeah, exactly. um and I guess maybe it's I mean they bring up like this comparison to SQL and things like that, which kind of doesn't come up afterwards. But it would be like a lot of these benefits, like you said, might not be super relevant if, for example, the hospitals were to agree on like a common system to use for communicating, right? And if that system is like centrally managed, okay, that's one con of it potentially,
Yep.
but it would solve the problems of like being able to communicate, or transfer records or things like that, right? Because like,
Yeah.
okay, look, all hospitals on the world use an AWS app, and yeah, Amazon, Jeff Bezos can like maybe delete it,
But I
but then you're
guess,
trusting Jeff Bezos.
but I guess maybe like like China might not want the U.S. to have access to these, like to control, or an American to have access to these records, right?
Yeah, exactly.
So you remove the this like favoritism of a. I don't
That's
know.
true.
I guess it removes the argument that it's easier to get worldwide adoption. I guess if no one can control this, than if
Yeah,
someone could control it.
yeah, I agree. That's a good point. um Kind of goes back to like that uh housing property project we were looking at, that we
Yeah,
thought was an issue, right? That like certain people don't trust like
the UN or
the
something.
UN, or yeah, which I guess I don't know, maybe, hey,
Yeah, I don't
who
know
knows.
either.
um let's not get political over here.
Well, it's not
Let's just say it could be that some people don't trust certain organizations.
right.
Now, so yeah, maybe it's a good equalizer, right? Like, look, we're gonna hospitals are gonna store patient records on this what decentralized system, and usually these things are now called dApps. So any kind of application where all the data and processing happens in a decentralized manner, so you get immutability, traceability, all this stuff, are called dApps. So if hospitals all use the same dApp to store their patients' records and track any kind of history, then the maintaining of that records is now trustless. Like hospitals don't have to trust a central authority to maintain those records and possibly not tamper with them. So yeah, I guess that does alleviate some possible tensions.
Right.
But it's not to say that yeah, I guess you're right. Once they've agreed to do one thing, then nobody gets to be the favorite, which is nice.
Yep.
You're right. Okay, and then the fourth, not the final, is robustness and availability. So like I said earlier, the standard database management systems do not suffer from single point of failure vulnerabilities. So it's pretty hard to knock down all the Amazon redundant servers, even though it's still a centralized system. But still, blockchain, they claim, I don't know if this is the case, still achieves a higher level of data redundancy. That's because every node in a blockchain system technically has to have an entire copy of all of the history.
Yeah.
And I don't know how that compares, for example, all the number of Bitcoin nodes versus the number of fully independent copies of Amazon Web Services.
But I mean, there are probably tens of copies of AWS.
Yeah, I guess.
And probably hundreds, if not thousands, of copies of the Bitcoin blockchain,
yeah,
right?
I guess.
But I'm sure there's a threshold, right?
Where it's like not necessary.
Yeah, do you need 30 copies of something? Do you if you have 30, do you need 100?
Well, I guess if someone were really trying to destroy Amazon, they would only need to go to 30 places, technically, which is a lot. Like it's always going to be.
Yeah, 30 extremely secure, extremely,
That introduces a cost, right? As well. Like you have to be super, super careful with these locations, right?
Sure.
Which is a cost on the user.
Yeah.
And I guess if you have a public ledger, then anybody is incentivized actually to maintain it, and so you have thousands of copies.
Right.
Obviously, like that introduces a scalability issue. Like I don't know if a peer-to-peer network has the potential to scale the way Amazon or a Microsoft cloud services have done. You know what I mean? Like if I add up all the PCs in the world, do I get as much compute power as Amazon has? Probably not. Yeah. It's an interesting point. Yeah, I haven't followed the citations on this, but it could be interesting to find other related topics, like research on these kinds of questions.
Yeah.
Because eventually they compare Bitcoin to Visa, for example, and I think they have some. I hope they cite a paper and not like some BuzzFeed article or something. Okay. So yeah, this blockchains are extremely redundant if they're public, such as Bitcoin. So Bitcoin transaction data is going to be extremely difficult to knock down because I can get a copy right now and someone would have to track me down and delete my laptop. And then the final benefit they give is security and privacy. And here I think that was a bit fuzzy for me because they say, oh yeah, everything, all the security behind blockchains is built on, these secure standards like the SHA and, whatever, all these hash and public asymmetric cryptography protocols, which, I mean, this is already, yeah. So
yeah,
all of any kind of centralized or database system is, if it's not coded by a 5-year-old, is already using like all these standards, right?
5-year-old or us.
Yeah, but maybe like what can I say with this? No, yeah, I didn't find this as really a bonus so much.
Yeah, I think the standard is very secure for communications across even centralized networks, right?
Exactly. Where it does make a difference is in terms of trust, right?
Yep.
where you have to, if you're giving your records to a centralized system, then someone has special permission over them. They might not be able to get your data, because if you give encrypted data to a centralized system, then they'll just have encrypted data, but they might be able to erase your records, for example, or somehow tamper. Okay. So they summarize the benefits as decentralized management. So you don't have to give anyone special permission to manage this data. You have an immutable audit trail. So because blockchains are immutable and time-stamped, any change in any transaction that occurs, whether it be financial or medical, there's always a full trail of how we got to that point. And data provenance, kind of the same idea. And then robustness, there's many copies of usually these decentralized public blockchains, so it's very hard to knock it down. Security and privacy, iffy, since it's not really different from what's already used with encryption standards. But yeah, those are the sort of high-level benefits. And then now they go into the medical applications, which I believe are four major topics. So one being medical record management, the other one insurance claim processes, and then biomedical research, and finally biomedical healthcare data management. A lot of these seem a little similar to each other, but let's go on. Yeah, so I think one big problem in medical data is like exchanging information across, like they say, patients, providers, payers, and any other party. So I guess patients and doctors generate data on a person, and then that data needs to be communicated to many different parties, right? Whether it be an insurance provider or another hospital or a pharmacy or whatever, there needs to be a good way to efficiently communicate it and make sure that there's no risk of forgeries or censorship or things like that, right? And so again, I think we touched on this already, but a good way to exchange data doesn't necessarily require blockchain, right? I mean, a data exchange, even if you were to run your system in a decentralized manner, you would still need for everyone that wants to use this service to agree on an exchange format or process, right? Like everyone say, okay, a medical record has this, and this data in this format, and that's what it's going to have. And if everybody agrees, then that's cool, but they could have done that on AWS as well, right?
Yes, but then, yeah, if they trust Jeff Bezos, basically.
Yeah. So then, okay, we have a cool exchange format. Everybody agrees. It's going to be super nice if all medical records look like this, and then everything's compatible with everything else. But then we have to trust that whatever's maintaining this data is reliable. And that's where blockchain says you don't have to worry about that. We can have this distributed over the network.
Right.
And I didn't follow these links, but they list a bunch of medical record management systems. MedVault, Fatcom, BitHealth.
Yeah, I don't know them.
That. I mean, maybe we can just quickly Google one of them. Which one do you want to Google? A famous example.
Okay, sure.
Okay. Guard time. Estonia. Guard time blockchain. Okay. Guardtime.com.
This is drug pricing, though, it says, right?
You think it's a different thing? Yeah, it could be. I typed in blockchain now.
No, I think it's blockchain for drug pricing.
Oh, but I thought their thing was for storing medical records.
Not sure.
It says benefits. Sorry. Guardtime is a company providing a blockchain-based system in Estonia to secure 1 million health records.
I misread. I don't know. I believe them, though.
I mean, what would that mean to secure 1 million healthcare records? Ah, there it is. Guardtime Enterprise Blockchain. Health APIs. Easy to use API for building distributed, secure, and compliant healthcare applications. Man, all this stuff is so vague.
Carlos, we've hit the 1 hour mark. Should we?
Oh, sheesh. Yes. got to speed it up. Anyway, maybe if we find something that's interesting, we'll probably do an episode on it.
Yeah.
Okay. And then I guess this is another like sort of trust-based issue, right? When you make an insurance claim, I don't know what goes into that, but I guess the insurance wants to make sure that whatever evidence you're providing for a claim is legitimate, right? And they would want to not have to trust some kind of authority, right, to validate that.
But you still gotta trust the doctor putting it on the record, right?
Yeah, for sure. I mean,
So,
yeah, go on.
no, I mean it's always you always have to trust somebody.
I mean, at some point, it's the real world, right?
Yeah, but I think, is it really helping you remove? Is it really giving you trustlessness? Like before, if a doctor cheated, they would have to pay, and now if a doctor cheats, they have to pay. Like they're removing this trust in like some other intermediate person.
Yeah, but
Okay.
you always had to trust the doctor, right?
Yeah, but now you have to like. I feel like they're fixing a problem that's epsilon compared to like very small.
Yeah, for sure. I get that feeling. I mean, I went to this webinar, this Block Apps webinar where they said, oh, we have a DApp for drug clinical trial management, right? And I think this paper mentions a similar thing, right?
Yeah.
It's like, oh yeah, there's many scientists have to like send each other results, and there could be like tampering in between. So we want like an auditable trail of immutable data. And then I asked the question like, okay, well, what if the scientist that like, did the experiment puts in an extra zero, in the whatever result,
even by mistake, like it.
Yeah. And then it's like, yeah, I asked the question to the guy who was like promoting this, and he was like, we're not focusing on that, we're focusing on this.
And I guess is that the relevant problem, I guess, is the question.
Yeah, I don't know. I mean, I guess it could be, right? Because if, I don't know, you're the experimental, I don't know, there's like two experimental labs collaborating and they have to send data to each other. Maybe like, okay, if the one that created the data was honest, then the rest don't have to be honest anymore, right? Like you just trust fewer people down the chain.
Yeah, maybe. I guess.
Like I send you my data, I could have faked it, I could have not faked it, but whatever I gave you, that's what's going to be used, right?
That's my data. Yeah.
And then if it turns out that exactly, and if it turns out that it was like fraudulent, it was me that did it, right?
But you can do this with a public key, like a signature, right? You send someone the data plus the signature that's your data.
Yeah.
And then whoever that person sends the data to has to also get the signature,
Yeah, that's true.
Like a hash of the data, you post a hash of the data.
Mm-hmm.
I don't know. It just feels like it's not, the blockchain is not necessarily for this.
That's very true. But then it goes back to trusting Jeff Bezos at the end of the day.
Yeah, sure.
Right. And again, the integrity of the data is also probably already easy to secure, right? Like you can't tamper with a hash chain, No,
I know, but what I'm saying is if the original person sends the data with a hash of the data,
mm-hmm.
and every subsequent person gets data checks on the server of the original experimentalist that the hash matches, then you still just have to trust the original data.
Yes. So you essentially create a hash chain, right?
Yeah.
And
it doesn't have to be decentralized is the point, I guess. Or trustless.
That's true. I guess where it might be more useful is if you start like doing logic on top of that data, no? Like if there's some kind of automatic way to approve insurance claims.
Yeah.
Then you can just like, if that's on chain, then that logic is provable valid, I don't have to like trust some back end of some server that like tells me whether or not my claim is legit.
Right.
But I guess that's really hard to implement, right?
Yeah, it could even be faulty code, like internal or whatever. Yeah, there are some things. It's just whatever.
But even then, right? Like if there were some like, I guess an insurance company could say, hey, look, we have an open source insurance claim sort of approval code. Here's our code. Here's the hash of our code. And this is like how we arrived at our decision on your insurance claim, you know?
Yeah, I guess they could do that too. Yeah.
The we always come to this, eh? So yes, you want to not have to trust Jeff Bezos to essentially like
Maybe the point here though
block
is
you.
the censorship,
Yeah.
aspect. Everyone is allowed to process insurance claims now, maybe, or something. Like you don't have to have a record on the person. Maybe it's enough to give a guy a quote based on his record.
Yeah.
And you don't have to have an identity associated to that.
True.
Like, what if the insurance provider just had your medical record?
Mm-hmm.
No, they didn't know who you were.
Mm-hmm.
Right. So they couldn't give you some, like, charge you more money because they knew you had money, for example.
Yeah, that's true. Although I would
Censorship.
imagine it's really difficult for insurance companies to go this way, right?
Yeah,
Like,
I don't know.
It feels like it's kind of deconstructing everything and saying like, okay, now you can use dictionaries on the blockchain, you know?
I'm just trying to find like I said, I think these are very, like, the problems they're solving are very small compared to what I see as the major problem.
Sure.
Anyways, go into the next one, I guess, right?
I mean, I guess at this point they all kind of become
they're the same, yeah.
Quite the same, right? And they apply it to clinical research, right? And I guess we've already went into that. So
yeah.
What I do find I'm always curious about is okay, so you want data to be tamper-proof, right?
Mm-hmm.
And I guess we can achieve tamper-proof data using, like what you said, some kind of hash chain, right? I don't know if like it can still be forged somehow on a centralized system.
No, but if you have a hash, how can you forge that, right? I guess if I provide the hash on my personal server, someone can hack my personal server, the different hash, and then send the fake data, right?
Yeah.
I guess that could be a problem.
Yeah.
But I mean, put 10 servers or something, like you can always multiply it on AWS, say, with 10 servers that have that hash. Okay, then you have to just trust Jeff Bezos. But let's say you use AWS and Google and, I don't know, Microsoft or something.
Yeah, for sure. But again, maybe it's just cheaper to do this then. If that's what you're going to do, maybe using a public blockchain is cheaper than paying Jeff Bezos.
Maybe.
So yeah, and then what I did find weird is this idea of like owning your data. I don't know if it was here that I read about it, but there's like these blockchain startups that say, oh, own your genome data, for example. We're going to store on the blockchain, and if a company wants to use your data, then they have to pay you for it. And
I guess this is the same stuff. Yeah, but I think this is the same thing. Like when you use your credit card, Visa or MasterCard probably sells your data to whoever, so they can advertise for you. But if you use Bitcoin, for example, they can't access that data unless they somehow correlate. Let's say use Monero, I don't know, some privacy coin.
Yeah.
But what you could do, I guess, is store that data, that purchasing data, and instead of Visa selling that information to some advertising company, you can sell it to them yourself.
You could do it once, right? But then they can just copy it.
Yeah, but then you have new data. You produce new data, right? Every day you produce new data by buying new stuff.
Maybe, but I mean, how often are you producing, for example, like medical records?
Yeah. So the thing is here, like I guess the point is,
or like DNA data.
Yeah. So let's say every time now they take your blood, right? They can get your DNA, presumably.
Yeah.
But maybe now they can't. It has to be uploaded to the server, this blockchain directly.
Yeah.
And you have the private key, and you can determine who you want to sell it to.
Yeah. But the point is, once you sell it to one person, it's over, right?
Yeah, but maybe, I guess, but it's better than selling it to 0 people, I guess.
Yeah, that's true. So maybe if you're continuously creating data, that's one thing. But, once... I mean,
not only that,
it's the DRM problem, right? Like, it's impossible to protect music from being pirated because everyone can just copy it once they see it.
Sure. But I guess the point is now it's other people selling your data.
Yeah.
Even if it's once, it's like it's someone else has your data and sells it and makes money off what you did or what you are or whatever.
But again, this can be done without a decentralized system, right?
Probably.
PayPal me and I'll tell you what my DNA is.
Um, yeah, maybe. Not sure.
I think
Yeah.
so. I mean,
But then you
the
got to, no, maybe you can write a smart contract, right?
sure,
Once the payment goes through, you get the person gets the data automatically.
sure, yeah, but that's just like on top of it. It's not. I don't think it's fundamentally um, adding any functionality, right?
No, I know, but I guess
I mean, it's nice that
I don't know.
the payment system and the data are in the same like place. You know?
Instead of trusting two different people, one to manage the data, one to manage the money,
Yeah,
you trust
that's
nobody, and it's just integrated. I guess. Yeah.
yeah, that's nice, right? If I could sell my DNA on Ethereum and at the same time get paid in Ether, boom. Um, that's probably just cheaper, right, than having to pay
But then
fees.
you gotta trust an exchange to convert your ether to US to Canadian dollars or
Well, not in a
dollars.
world where I just buy
Yeah,
things with Ether, right?
sure. I
2022.
maybe.
Um, yeah. So that again, I've seen so many times like, oh yeah, blockchain is going to help people like own their data again. I don't know. Um, it seems like it just goes back to the problem of censorship, I guess. Um,
Yeah,
and
they're all the same. I mean, they're all the same. A lot of the applications we've seen, it's hard to make the connection to the next level.
mhm,
Where it's like, yeah, you're solving this. I understand the problem they're trying to solve, but is that the relevant problem? Who knows?
yes.
I wish they would present like this is why we're solving this problem. This is why it's an issue, and then solve it. You know?
Yeah. I guess maybe we can probably look more closely at one of these projects and see like, okay, this is
Sure.
actually what they tried to do.
Yeah. Yeah,
Does
we're
it make
talking
any
as if
sense?
we know the whole thing, but maybe there are some projects solving some very specific problems that are very useful to solve.
Yeah, for sure. What did I say? Oh yeah, I highlighted um, that Bitcoin has a theoretical maximum transaction processing rate of 7 transactions per second, whereas Visa has a theoretical max of 4,000 transactions per second.
But this is a scaling issue, right? That people are trying to solve in different ways.
Yeah,
Like
absolutely.
The Segwit probably made this better,
Hmm.
and this was pre-Segwit. Also, Bitcoin Cash probably has a better throughput
Yeah.
because the blocks are bigger.
Hmm. And I think, okay, I wanted to discuss this thing, which we already did, which was like the problem. So in this section, they're basically coming up with some issues that blockchain comes with. So one is what we just mentioned. Often there's scalability issues. So since you have very large networks verifying these computations, you want to make them as lightweight as possible. And sometimes that can make things a bit slow. Um,
But honestly, how many times are you updating a medical record, right?
yeah, for sure.
It's at most once a day. I don't know.
I mean, yeah, not that many, I guess. Definitely way fewer than Visa transactions. Um, so yeah, but that's one drawback. Scalability. It's always been an issue for blockchain, but now there's a lot of things that are addressing that quite well. Like Perry said, SegWit. And then the other one is transparency and confidentiality, right? Since this network, if you're implementing a public blockchain, all the data on the blockchain is fully uh, visible to everyone. It's only, so they say it only has read access and append access. So you can only create new records and you can only read existing records. So you can never overwrite them, which is a nice feature. Um, but the point is everybody can read it. So any kind of data that's not encrypted on the blockchain can be accessed by everyone else. So you have to be careful when you're implementing these kinds of things to make sure that anything if you want to back up some sensitive data, you either store a pointer to that data, which points to something that's encrypted, or an encrypted pointer to that data. Um, but whatever goes on the blockchain is going to be known by everyone, right? And usually in things like Bitcoin, it's not an issue because an address doesn't store any information about a person. So in a sense, you have what they call pseudonymity. For medical records, you would want to make sure that you still maintain some privacy by uh, essentially uploading to the blockchain a proof that that data exists and that it's sort of a check that anyone can make to verify the integrity of some data that's not stored on the blockchain. or something that's directly encrypted.
I guess the point is for me, this is like you trust a doctor already, right?
Sure.
So why can't you make a system that goes between doctors?
Mm-hmm.
So no one can see your data except the doctors. There's
Mm-hmm.
a way to generate a private public key pair when you get your medical license,
Mm-hmm.
and then you can see all the patient, like you can see the information on the patients.
Oh, I see.
Like maybe
Yeah.
it's encrypted, and then when I go to my doctor and he becomes my doctor, I give him my private key, or I just sign him. I just send him some information through the DApp that unlocks my records, for him
Mm-hmm.
or her.
Yeah. Exactly. Yeah, I guess so. But again, you gotta trust the doctor, right?
You already trust the doctor. That's my point.
Yeah.
You're already trusting the doctor with everything.
For sure.
He like right now he can already. I don't know. Yeah.
The doctor can basically publish, can rat you out to any insurance company, right?
Even if it's encrypted or whatever,
Mm-hmm.
at one point he still has to decrypt it to see it, and then he can sell it at that point.
Yeah.
So a dishonest doctor can ruin this no matter what happens, right? Because eventually he has to see the unencrypted data.
Mm-hmm. But I guess
He or she.
he or she, most likely she. I think there's more female doctors now than male doctors.
There you go.
So yes. So the point is, I guess, if ever anything goes wrong, or like nowadays, maybe like a medical record passes through many hands, right?
I'm not really sure yet.
And
Yes.
let's say that's the case.
Yeah.
If on like an immutable ledger that's decentralized, yes, the doctor has to create a legit medical record for you, but then afterwards any kind of tampering can be detected easily, right? Again, I think this can also be implemented with a centralized system.
Yeah.
Just trust Jeff Bezos, man.
Maybe we contact the author of this to give us a little.
We should, yeah. I would love to. I would love to have a deeper chat on this. I'll do that. Let's do that for every paper we read.
Yeah. Should we go through the conclusions? I mean, there's not.
Yes, let's do that.
Maybe wrap it up.
I also wanted to say that often, I don't think they mentioned it in the paper, but often, once you've written a DApp or a decentralized application, since it technically becomes, the code itself becomes a record on the blockchain, and it becomes immutable. So it makes it very difficult to upgrade or modify functionality, right?
I mean, I guess you have to make a new DApp and then migrate all the records from the old DApp to the new DApp.
Yeah. So you can never say like, okay, the new version of my DApp is like still in the same place. It just has a new functionality. You have to actually create a new DApp.
And you have to get people to agree to use the new DApp, basically.
Yes.
They can always just use the old app.
That's definitely quite messy. And I don't know if there's probably better ways to do it now, I would imagine. I remember Alessandro was talking to us about the ENS being able to letting you like update your code much easier than that. I
think you just set the ENS pointer to something new, right?
Yeah.
Like if you access carlos.eth and it points you to your current DApp, and then you change that address to some other DApp,
sure.
Then someone accessing carlos.eth goes to the new DApp,
Okay. Yeah. Speaking of which, we own delphicrypto.eth.
Oh, no.
Maybe we should buy ozeki.eth.
Sure.
Oh my God, 1 sec. ETH claim. OZEKI. Oh, it's not going to be it's not going to be above the minimum name. Whoa. ENS. What? I put ETH.
ENS, you can just do Ozeki.io.
Yeah, I guess. ENS.domains. Let's see. I think it has to be above 6 letters, right?
I can't remember actually.
Or like they pre-claimed all the short ones.
But if you go up, I think the names expire. Names bought in May are expiring soon.
Whoa, okay, so we definitely don't own.
I think you have to keep buying it.
Maybe.
That's annoying.
Where do I look up? Wow, there's a lot of dApps on here. Am I looking in the wrong place here?
I think you have to open your Ethereum wallet.
I just want to check if that exists.
Oh.
I just want to check if a domain name exists. Oh, I guess you're saying they don't have a.
You need to access the blockchain somehow, right?
Mm-hmm. Oh, I remember in the past I was able to just like search for a name, but I think they have like specific sales at certain times now.
Maybe. I'm not sure how this works anymore.
Damn it! Oh, that's not fun. Oh, there it is. Boom. Ozeki. Oh no! Wait, does that mean it exists?
1 year. You can only buy it for 1 year now. Wow. They changed it.
Oh my god, we're buying this.
Let's buy it offline though.
Yeah, sure. My private key. Okay.
Do you want it? Conclusions, or just we should
Conclusions.
maybe wrap it up?
Let's just do a quick little conclusions. So I think I'm upset because we're back to where we started. I was hoping to go into this and be like, oh my god, look, there's this problem in the medical community that blockchain clearly solves, and like this is the gain that we get. But it seems again like, I mean, this is a review paper, so maybe they didn't have time to go in detail.
Yeah.
But it seems like everything that these blockchain applications boil down to is preventing censorship to happen on these networks, right? So because no one has a special authority, no one can block you from using these, from being a member of these networks. I don't know like how much that's relevant for the medical community. I guess like you brought up a good point that maybe if many entities wanted to have a good way of communicating with each other, but don't necessarily want to cede control over the maintaining of these records, then having some kind of decentralized protocol would be useful there.
Yeah.
And I guess the single point of failure or the redundancy element is probably still pretty useful, I guess. I would imagine that it's quite expensive to run, a full inter-hospital communication system, right, on a centralized server. Maybe it's cheaper to do it in a decentralized way, since like the decentralized system has a built-in like financial incentive for people to participate, right?
The thing
Which
that's
is nice.
the money's not mentioned here, right?
Yeah.
So the way this is written is not about like it's cheaper to do it this way either, right?
That's true.
It's always like we're trying to solve this problem.
Mm-hmm.
Like I think it being cheaper is a perfectly good solution. Like it's a perfectly good reason to do something.
Yeah.
But these things are never, well, not never, but from what we've read, I think we never get the impression that the reason they're doing this is to solve this expensive, like to solve the problem of it being too expensive.
Yeah. So usually, and what I've heard many times is we use blockchain in the medical or the drug development clinical trial is because there's many entities that are trying to communicate with each other, and there's no like agreed upon way of doing that, right?
That's
and
like
then,
Slack, use Slack or something,
Yeah. So then I think, but what ends up happening, I think, is there's like many transfers of data between people that are kind of like unchecked or undocumented.
Yeah, maybe.
And then you don't know like, oh my God, this patient's record is all of a sudden like something else. And I don't know like who changed it or what happened. And I think people that are developing blockchain solutions are trying to address that with blockchain, and it's probably something that would work. But I think what Perry and I have discussed many times is that it's not the only solution, that you could do this in a centralized manner. All you have to do is give up some trust for essentially some cloud service to not like, ban you from using them, right? Or something like that.
Yeah. So my feeling is that if you can get rid of trust completely, you might as well trust someone, like someone that you're almost sure cannot screw you over, but gain all the benefits of having a centralized system,
Yeah, because they only mention that there's scalability issues and privacy issues with blockchain, but also I think there's very, very high like practicality costs as well.
Yeah, so it is, as of today, very difficult to use, right?
For sure. I mean, I think in the last few years there's been a lot of efforts to make it a lot easier to develop like actual enterprise level solutions. So maybe we can get into that later. But it's just like on a theoretical level, it's going to impose a lot of constraints, right? The fact that you're running this logic on a global network in a immutable way becomes quite challenging.
Right.
Okay, so I think we should end it there.
Yeah, sounds good.
I'm gonna go through the references, see if anything interesting comes up on this paper.
Reference 60. I looked at reference 60 because it talked about something that I can't remember what it was, but it talked about something that
reproducibility crisis. Yeah,
that we were
we
thinking
did talk about this.
Maybe this is a next paper or something, but
it's not even an article. It's not even a paper.
It's a blog. Yeah, that's why. That's why
I think I read this. Oh yeah, it's Sunke Bartling. It's the guys from Blockchain for Science.
Okay.
It's again, immutable research database, right? Nobody can go in and change the numbers.
Sure.
This you can do on AWS, correct?
I think so.
Yeah. Although I guess you would have to set it up in a way such that nobody has like modify access somehow, right?
Yeah.
How you can do that. You just have to trust the AWS sysadmins to do that for you. Okay, yeah. So upload your Excel to the blockchain. There you go. Man, this is PRA. Could blockchain provide the technical fix to solve science's reproducibility crisis?
Is it a crisis, number one?
Yeah. No, but I think we had an idea for this, a little more sophisticated, if I may say so myself.
We'll get to that eventually.
We're going to get to that. Okay.
Okay. So thanks, cool. Carlos. I guess we'll see
you,
everyone
Perry.
next week.
I'm excited. Yeah. Let's what was I going to say? Oh, I completely shut down. Yeah. See you next week. And I'm excited to see your thesis is what I was going to say.
Yeah, cool. I'll send it to you as soon as I finish.
Are you going to put it on the archive? Oh, no, you don't have to put it on the archive. It gets automatically. Yeah. Sweet. All right. Well, good luck.
See you later.
Ya. Ciao.